Welcome everyone. We are discussing continuity. Today I will discuss some problems of Wbjee and JEE main. So look, 1 and 2. So problem number 2. Fx equals to 1 plus x whole to the power cot x be continuous at x equals to 0. Then find value of f0. So f0 is continuous. We have already discussed many problems of this type. So f0 equals to limit x tends to 0 fx. Since it is continuous, f0 equals to limit x tends to 0 fx. Now this equals to limit x tends to 0. What is fx? 1 plus x whole to the power cot x. Now, if we put x equals to 0, this is 1. So 1 to the power infinity form. So we have already discussed it. If it is of the form 1 to the power infinity, this is fx. Fx is 1 plus x and gx is cot x. So fx to the power gx is fx minus 1. So 1 plus x minus 1 whole to the power into cot x. So this one is result limit x tends to a fx to the power gx. If it is 1 to the power infinity, then this equals to limit x tends to a fx minus 1 into gx. So this equals to limit x, this is e to the power. This is e to the power limit x tends to 0. So e to the power limit x tends to 0 x cot x. So x by tan x. You can write. Now standard result is tan x by x is 1. Therefore x by tan x also 1. So e to the power 1. So what is value of f0? f0 equals to e. So option C is correct. A very simple problem, Wbjee. Next problem number 1. So fx is continuous at x equals to 0. Same problem. f0 equals to limit x tends to 0 fx. So limit x tends to 0, 36 to the power x. So you can write 9 to the power x into 4 to the power x minus 9 to the power x minus 4 to the power x plus 1 by root 2 root over 1 plus cos x. Now it reduces to the problem of limit. So look, we rationalize it. So this is 2, 1 minus 1 plus cos x, 2 into. And to make it balance, root over 2, 1 plus cos x. And if you factorize it, this will be 9 to the power x minus 1 and this is 4 to the power x minus 1. Now we know rationalizing factor, this creates no problem. So you can put x equals to 0. So limit x tends to 0, root 2 plus 1 plus cos x. And this is limit x tends to 0, 9 to the power x minus 1, 4 to the power x minus 1, 1 minus cos x. Now this equals to, if we put x equals to 0, so this is root 2 plus root 2. And you know 1 minus cos x by x square is half. So 9 to the power x minus 1 by x. So a to the power x minus 1 by x as x tends to 0 equals to log a. So this is 4 to the power x minus 1 by x. So x square is balanced. If you put x tends to 0, x tends to 0, no need of writing this in case of competitive exam. So you write directly. This is 2 root 2. This is log 9. This is log 4. And this is half. So 4 root 2 into 3 log 2 into 2 log 2. So 3 into 6, so 24 log 2 log 3. 24 log 2 log 3. So let us verify again. Answer is not matching. So 9 to the power x minus 1, 4 to the power x minus 1. 2, 1 minus cos x. So this one, rationalizing factor, it creates no problem. So root 2 plus root 2, okay. 9 to the power x minus 1, 4 to the power x minus 1 by x. 1 minus this. So this is 2 root 2. This is log 9, log 4 half, 4 root 2. So this one is, log 9 is 2 log 3, 2 log 3. This is 2 log 2. So finally, 4 into 2 into 2, 16 into log 2 into log 3. Obviously, base is E. So, rationalize, then use standard result if possible. No need of using L'Hospital rule for this type of problem. Next. Now we consider two similar type of problems. So 3 and 4, most important problem. Fx equals to x square sin 1 by x, x not equals to 0, x equals to 0. Then f and f dash are continuous, f is differentiable, but f dash is not continuous, f dash is differentiable at x equals to 0. So, we know x square sin 1 by x. X square sin 1 by x, x not equals to 0. This is 0, x equals to 0. We have already solved this problem. This one is both differentiable and continuous. Why? You look, f dash x equals to x square, derivative of sin 1 by x is cos 1 by x into minus x square. Cos 1 by x, so minus 1 by x square, plus 2x sin 1 by x, x not equals to 0. So actually it is minus cos 1 by x, 2x sin 1 by x, x not equals to 0, equals to 0, x equals to 0. So look, fx equals to, we know, limit x tends to 0, this is our standard result, x sin 1 by x equals to 0. So, limit x tends to 0, x sin 1 by x equals to 0, and limit x tends to 0, sin 1 by x does not exist. Cos 1 by x, in case of cos 1 by x, same result does not exist. So, if it is x sin 1 by x, then limiting value is 0. So, fx equals to x square sine 1 by x. So f0 equals to limit x tends to 0 fx equals to limit x tends to 0 x square sine 1 by x equals to 0. So f is continuous at x equals to 0. Now regarding differentiability, f dash x, limit x tends to 0 x square sine 1 by x minus 0 by x minus 0. Actually this is fx minus f0 by x minus 0. Formula of f dash 0. This is f dash 0. So this is limit x tends to 0 x sine 1 by x equals to 0. So f is derivable. So what is our observation? F is both differentiable and continuous at x equals to 0 for x square sine 1 by x. So f is differentiable at x equals to 0. This is true. Now regarding differentiability of f dash and continuity of f dash. Look, f dash equals to this. So minus cos 1 by x is minus cos 1 by x does not exist. Cos 1 by x does not exist. So f dash is not continuous. We are getting this one. F dash is not continuous. F dash is not continuous. So here f is continuous, but f dash is not continuous. So this option is not correct. F is differentiable. Yes, it is differentiable and f dash is not continuous. This is true. F dash is differentiable at x equals to 0. So if we find differentiability of f dash, we need this one. So look, f dash x. So limit x tends to 0 cos 1 by x does not exist. So f dash is not continuous. We have already discussed. And regarding differentiability of f dash, so if you divide it by x, so what is differentiability of f dash? Derivative of f dash, that is derivative of f dash then derivative, limit x tends to 0 f dash x minus f dash 0 by x. So if you divide f dash x by x, this will be sine 1 by x and this is 1 by x cos 1 by x. So derivative of f dash does not exist. F dash is not differentiable. F is differentiable, mind it, but f dash is not differentiable. So we are getting two options. F is differentiable, but f dash is not continuous, and f is differentiable at x equals to 0. Now this one, x to the power n sine 1 by x. You remember it. If n greater than 1, then it is x square sine 1 by x. X cube sine 1 by x. So for greater than 1, it is differentiable. For greater than 1, it is differentiable. But if it is x sine 1 by x, fx equals to, here n equals to 1. So what is f dash x? Limit x tends to 0 x sin 1 by x minus 0 by x. So limit x tends to 0, sin 1 by x does not exist. Does not exist. So you remember x sin 1 by x is continuous but not differentiable. So f is continuous and differentiable at x equals to 0. If f is continuous and differentiable at x equals to 0. At x equals to 0. F is continuous and differentiable at x equals to 0 if n greater than 1. That is 1 to infinity. This is 1 to infinity. It will be 1 to infinity. Greater than 1. Greater than 1. F is differentiable and continuous. Now, if n is 1, then it is continuous but not differentiable. So, you remember this result. Now, we consider 3 more problems, 5, 6, 7. Look, problem number 7. The set of points where fx is differentiable. Fx is given. It is differentiable at x equals to 1, find a and b. And the function fx equals to 1 plus mod sin x is continuous everywhere, continuous nowhere, differentiable nowhere, differentiable at x equals to 0. So, their problem of differentiability and continuity. So, we know a remarkable theorem. Every differentiable function is continuous, but converse is not true. That is, if a function is differentiable, then it is continuous. No need of verification of continuity. So, problem number 5. So, fx equals to 1 plus mod sin x. So, 1 plus sin x. So, for x greater than for greater than 0. So, for greater than 0. 0 to you can write up to pi you can write. So, you are interested about 0 only. So, this is suppose negative minus pi less than x less than 0. So, for less than 0. And at x equals to 0, it is 1. X equals to 0, it is 1. So, what is f dash x? 1 plus cos x. And this is 1 minus cos x. Equals to 0 at x equals to 0. So, look, restriction is imposed. So, at x equals to 0. At x equals to 0. So, at x equals to 0. So, what is f dash 0 plus? It is 2. F dash 0 minus. So, this is 0. And f dash 0 equals to 0. So, fx is not differentiable at x equals to 0 at x equals to 0. So fx is not differentiable. Now 1 is continuous function and mod sin x is continuous function. So sum of two continuous function is continuous. So option A is obviously correct. It is continuous everywhere. It is continuous everywhere. And look, we have differentiable, continuous, and what is the last option? Last option is not differentiable at x equals to 0. This is not differentiable at x equals to 0. So this is also proved. Continuous nowhere. This is not correct because it is continuous everywhere. Differentiable nowhere. Differentiable nowhere. It is not differentiable at x equals to 0. But look, it is differentiable in between 0 to pi. In between 0 to pi. So this option, option A and option D is correct option. Now, if you consider the graph of 1 plus mod sin x, 1 plus mod sin x, at 0 it is 0, at pi it is, at pi it is 1. So graph will be like this. This is 1. So this type of graph. Mod sin x for x equals to 0, this is 1 plus sin x. So look, graph, from graph it is continuous for all this. But it is not differentiable at 0, not differentiable at pi, not differentiable at 2 pi. So differentiable nowhere, it is not correct. It is differentiable in between 0 to pi, in between pi to 2 pi. So this is also verified from graph. Now problem number 7. The set of points where fx is differentiable. So look, this is x by 1 plus x, x greater than 0. This is x by 1 minus x, x less than 0. So at x equals to 0, this is 0 by 1, this is 0. So you have to check differentiability. So what is f dash x? This is 1 plus x whole square. 1 plus x into 1 minus x into this. So 1 by 1 plus x whole square for x greater than 0. For x less than 0, 1 minus x whole square, 1 minus x unchanged into 1 minus x unchanged, and 1 minus x derivative is minus 1. So finally minus x and this is plus x. So 1 by 1 minus x whole square. So what is f dash 0? For this is less than 0. So f dash 0 plus is 1 by this, 1 by 1 plus 0 whole square, and f dash 0 minus, for this restriction it is also 1. So f is differentiable at x equals to 0. Now condition is imposed only on x equals to 0. So no need of verification to other points. It is differentiable at x equals to 0. Hence, it is differentiable for all x. So, it is differentiable for all x, that is minus infinity to plus infinity, that is in R. So, you calculate f dash x for these two restrictions, find f dash 0 plus and f dash 0 minus. So, it is differentiable throughout the real number. Next, fx equals to, this is differentiable at x equals to 1. Find a and b. Find a and b. So, fx equals to, so restriction ax square minus b. So, this is minus 1 less than x less than 1. So, this is for greater than 1. This is 1, x greater than 1, mod x is positive. So, what is f dash x? F dash x equals to 2ax minus 1 less than x less than 1 equals to, for greater than 1, this is 1 by x, sorry, mod x is x. Mod x, what is value of mod x? Mod x is x. So, f dash x minus 1 by x square, x greater than 1. So, it is differentiable at x equals to 1. So, since fx is differentiable at x equals to 1, f dash 1 plus equals to f dash 1 minus. So, for 1 plus, it is minus 1 by x square. So, this is minus 1 by 1 square. And for 1 minus to this restriction, this is 2a into 1. So, a equals to minus half. So, what is a? A equals to minus half. So, we are getting a. Now, we have to find b. So, there is no restriction involving b in f dash x. So, we use the remarkable theorem. It is continuous at x equals to 1, differentiable at x equals to 1. fx is differentiable, it is given at x equals to 1. Hence, fx is continuous at x equals to 1. Therefore, f1 plus right hand limit equals to f1 minus. So, for 1 plus, it is 1 by 1. So, for 1 minus, this is a into 1 square minus b. So, a minus b equals to 1. So, what is a? A is minus half, minus b equals to 1. So, b equals to minus 3 by 2. What is b? b equals to minus 3 by 2. We are getting only one restriction. So, one more differentiable at x equals to 1. So, we are getting one more condition. It is also continuous at x equals to 1. Next, now you consider two more problems, problem number 8 and 9. So, fx equals to this, derivative of function is everywhere continuous, prove that a equals to 2, b equals to 2. So, you find derivative and use condition of continuity at x equals to minus 1. You get one condition, and since derivative is continuous, function is continuous, so you use definition of continuity of fx at specified point x equals to minus 1. You get two conditions and two equations. Solving, you get A and B. So you solve it. Now rest one. Ninth. So e to the power 1 by x. We need a result. So here I have already discussed, if x lies between -1 to +1, then x to the power n tends to 0 as n tends to infinity. And if x greater than 1, then x to the power n tends to infinity as n tends to infinity. If n is large, then if x greater than 1, value is very, very large. But it lies between -1 to +1, then x to the power n tends to 0. So look, problem number 9. Obviously, f0 equals to 0. So, as x tends to 0 plus, 1 by x tends to infinity. Therefore, e to the power 1 by x tends to e to the power infinity. Therefore, e to the power -1 by x tends to 0. Similarly, as x tends to 0 minus, 1 by x tends to minus infinity. So, e to the power 1 by x tends to e to the power minus infinity. So, this is tends to 0. So, e to the power infinity is e to the power 1 by x tends to infinity because e is greater than 1. So, reciprocal of it is 0. So, these are our working tools. X tends to 0, 1 by x is infinity, e to the power infinity is infinity since e equals to 2718. It is greater than 1. And e to the power minus infinity, e to the power infinity is infinity, so e to the power minus infinity is 0. So, what is right hand limit? Limit, this is called f0 plus. Limit x tends to 0 plus e to the power 1 by x minus 1, e to the power 1 by x minus 1. So, e to the power 1 by x tends to infinity. We do not want to put infinity value. So, divide by e to the power 1 by x. Divide it by e to the power 1 by x. Now, e to the power 1 by x tends to 0. So, 1 minus 1, 1 minus 0. So, this is 1. So, right hand limit is 1. Now, what is left hand limit? Left hand limit equals to f dash 0 minus limit x tends to 0 minus e to the power 1 by x minus 1, this is plus 1, this is plus 1, sorry, this is plus 1, e to the power 1 by x plus 1. So, as x tends to 0 minus, e to the power 1 by x tends to 0. So, you can put 0 directly, 0 minus 1, 0 plus 1 equals to minus 1. So, right hand limit, this is f0 minus, right hand limit not equals to left hand limit, left hand limit. So, f is not continuous. F is continuous at x equals to 0, this is wrong. F is not. So, look again. Right hand limit is 1, left hand limit is minus 1. Right hand limit not equals to left hand limit. So, it is not continuous at x equals to 0. So, option B is correct. Option A is it is continuous, so it is wrong. And right hand limit not equals to left hand limit, so it is called irremovable discontinuity. By changing definition of fx at x equals to specified point, that is x equals to 0, it cannot be made continuous. So, fx is not continuous at x equals to 0, but can but can be made continuous at x equals to 0. It is wrong. It cannot be made continuous. So option B is only true option. This is most important problem. So through this video, I have discussed some important problem of continuity and differentiability. So you practice these type of problems. These are most important problem of competitive exam. Thank you today.